Today we shall be discussing about the third chapter from our physics portion of the syllabus, that is gravitation, right? In our first two chapters, we were discussing about motion of an object, and then we also had a discussion on force as a cause of that motion of a particular object, right? Okay, now there are many instances where we observe after reaching a maximum height, it tends to fall back. Okay, and then we also know about the concept of planets moving around the sun, right? And we also know about the motion of moon around the earth. There is some force responsible for it. Object namle yusuna masala saya. Planets sun la revolve chia. Moon gi earth la revolve chia. There is a force responsible for it, and that particular force is called as gravitational force. And gravitational force applies here phenomenon we call it as gravitation. Right? Gravitation counts in the sumba shiva nala tissue la ni chayur tissue ra ani object shimba ji kuran chola chu thingi yuna dinde gi shu chila ganzugi tissues yana gravitation law or ra earth ki an object changma there is a force which attracts all the object towards the center of the earth. The force, earth ki gravitational force la, we have a specific term which is called as gravity. Gravity la we are specifically referring to the gravitational force of the earth. So gravitation la is nothing but a force which is responsible for the attraction of one object towards another object. Object ni gi an pa to attract chi gi force dila gi gravitational force la reles. Now when we observe object moving in a circular path, circle chinala move chi, let us take an example of moon revolving around the earth. Ani ta dela ani gravitational force digi ani earth gi gravity digi ani moon di earth will attract chi la. But then, while moving around in the circle, we do not see moon falling towards the earth. So attract chigo there in a circle chinangla move chijiba de or so earth chola fall chigo ding and observe chigo marwa. That is because of any centripetal force acting on the moon. Earth ki any centripetal force the moon gala act it keeps on moving around in a circle. Chazwa taduksine gravitation che Okay, now object shimbas gonna force exert na. We have studied in Newton's third law of motion that every action has equal and opposite reaction. Force to exert Now let us take an example. Isaac Newton ki observation keta chimbo ko shingdon ji wall de kushu shingdon ji wall de kushu masar helas. Right? I quick did de la khari deduce shilana and earth ki gravity di kushu mathin helas. Now applying third law of motion. Third law of motion applies chisuna earth ki kushu ma thingyo ki force dida chikpa chikya kushu ki earth ya thingyo ki force. Here the Newton ki third law of motion nala every action has equal and opposite reaction with you kushu ma saya the action ina earth chola thini center of earth chola attract chine kushu ma sagi na. In the same way, apple has to exert equal amount of force on the earth. Right? But then we do not see earth moving towards the apple. Earth, the apple chola move right? It is not evident, right? That is because action and reaction takes place on a different objects. Object loga. Action the apple cannot take place mass of the earth compared to the mass of the apple is very large. So think of the evident here. In a apple ki mass the earth ki mass nika comparatively apple ki mass the back so ya think of the tongo marel, but then equal amount of force is being exerted. Force a pasuniga la chipuchika exert chigo Okay, so that is all about gravitation. Now the object ni pa to force exert chigore, gravitational force exert chigore vela ra. So there is a very important law associated with gravitation. Ra gravitation the devata ne ani law pe ke chumbu jure di law di khari vela na universal law of gravitation. Okay, and then this law is very important from your examination point of view as well. Right, okay, now universal law of gravitation, what is being given there is, let's suppose we have two objects, object A and object B. Right, now according to universal law of gravitation, okay, let's suppose object A ki mass the capital M che, object B ki mass the small m, right? And the distance between two objects is D. Right? D ni ki paru ki distance C. Let us suppose there is a distance D between object A and object B. Now gravitational force object A will exert certain amount of force on object B. In the same way, object B will also exert certain amount of force on object A, right? According to universal law of gravitation, every object in this universe tries to attract another object with a force which is equal to force exert a force which is directly proportional to the masses of the objects involved, right? So force is directly proportional to the product of masses involved here, right? There are object ni ki mass the multiply chisuna force the directly proportional real, right? Now directly proportional ladu there are variable ni che dwa. We have two factors here, right? Force and mass. Now directly proportional means if there is more mass, it means more force. When there is lesser amount of mass, lesser mass, it means the force applied will also be lesser, right? So those are directly proportional ladi force ma yidu mass ma yuwa tingore force nyuwa yidu mass nyuwa yuwa, it automatically indicates that, right? So according to universal law of gravitation, every object in this universe tries to attract another object with a force which is directly proportional to the product of masses and inversely proportional to the square of distance between them. Inversely proportional so here, distance kaze ki tha ringa yuna force nyunga yure. Distance kaze ki nye yuna force manga yure. Ra, tadi nganzo simple example to consider chida ra. Nganzo ki ta tha nye kaze mil devada na ra. Pinga da dinde ne bero kaze nganzo mi tha nye yugo de la nganzo deva shukche li dwa. Force ma indicates an example to put dara. Ani tarimbo yugo de la nganzo kaze ne deva che di ka dwa. Tikuji kyare de la ra. Distance the inversely proportional real du tha kaze ki ringa yuna. Digam ki en khari force the nyunga koni poro ki force of attraction la warda. Force of attraction chik thinagi force yorwa di nyunga yore. And when there is more lesser distance, kaze ki tha nye lesser distance la du tha nye la warwa. So tha nye yudu, what happens is the force exerted by object pasu force exert chigyo di ani manga yelo when there is lesser amount of distance involved, right? Okay, now let's combine these two equations. Combining these two equations, we get force proportional to sign product of masses divided by square of distance. Right? Now, if we remove this proportionality sign, constant dictated. So here, okay. Now you must be wondering what is this G? The G the kharwela. So G here is known as gravitational constant. G the kharchagirwela na gravitational constant is and the value the given value for G is 6.673 into 10 raised to power minus 11 Newton meter square per kg square. The value is given there. Right? Okay, so now here, force is equal to gravitational constant, mass of object A into mass of object B divided by square of distance between these two objects. This is one. Okay, now arranging this formula. The formula, the universal law of gravitational mathematical expression there. Now in arranging this formula, we have G is equal to F the d square so dana into say into d square divided by capital M into small m. So yeah, this is how we find the value the gravitational force. Gravitational constant ki value di and by applying this formula di apply chine gravitational constant ki value di le. Is it clear? So here, this is how we explain the universal law of gravitation, right? Two objects attract each other with a force which is directly proportional to the product of masses and inversely proportional to the square of distance between them. Right? And by arranging the equation, we get F proportional to sign m into small m divided by d square. And if we remove this constant proportional to sign, we get a constant g, right? The g the gravitational constant and g value the dusre, right? And this is the formula to calculate g. G can just calculate formula the apply chin calculate g. So I hope it's all clear, right? Now, universal law of gravitation is considered one of the very important laws, right? Which helped us in describing certain phenomena which were earlier been believed to be disconnected. Right? Phenomenon explain Shugula with the universal law of gravitation. Universal law of gravitation dishe kya yundi ani phenomena zinzo and seupe chare the force that binds us towards the earth. Nganzo earth center of earth ki ani earth ki gravitational force exert chine object thongma ani center of earth chola thingi or the concept declare chare. And then the concept of movements of planets around the sun, moon around the moon, earth. This is clear. It also helped in explaining the tides due to ani sanda, moon gi, ani high tide, low tide lagi phenomenon the ruwa. This explain universal law of gravitation gi ani helped here. So that is why it is considered as one of the very important ani laws associated with gravitation. The gravitation ki universal law of gravitation ki concept is high. Now let us talk about free fall. The free fall like it's mangu khoir. Mami jam gagali tu and free fall ganye in and kitchen show. So now what is free fall? Free fall and when an object falls from certain height under the influence of only gravitational force. Gravity and influence na and that object is said to be in a free fall. Object di any free fall so it is when object falls from certain height only under the influence of gravity. Gravity influence na and free fall the free fall discussed what is important is acceleration due to gravity. So here, last one. Chalaji ani height in masagi over mass any gravity influence nala masagi na the object free fall or else. The mass kugi any object move to go move chigi ani kharisho chigorlana velocity change chigi so velocity change chigi there is an acceleration involved, right? So here acceleration is due to the gravity. Free falling objects nala acceleration di gravity ki kimbe yongorwa. It falls only under the influence of gravity, so therefore the acceleration involved here is also due to the gravity. So in that particular case, kisi dinde ki case nala, what we call acceleration dila, we tend to call it as acceleration due to gravity. So free falling objects nala acceleration yugo di gravity lekin be yungu yuza and dila hanzo ki acceleration due to gravity legre, it is denoted by letter small g. Ra ta mabu ya thugu yuda. Tajing also universal law of gravitation discussed shidu, we were talking about gravitational constant, which was denoted by letter capital G. Here we are talking about acceleration due to gravity, and it is denoted by letter small g. Tinika ki value back lower da. Capital G the gravitational constant, whereas small g symbolizes acceleration due to gravity. Okay, now since there is a numerical value involved with acceleration due to gravity, so we also have a formula to calculate this value, right? Formula LS. Now we know that force is equal to mass into acceleration. Because in second law of motion describes the mathematical expression D and derive right? Okay, now since in case of free falling objects nala acceleration the gravity ki be yungu, we can also write it as F is equal to m into g, where g stands for acceleration due to gravity. Okay, now using the mathematical expression for gravitation, universal law of gravitation, we have force is equal to g capital M into small m divided by d square. Universal law of gravitation. Now applying the value of F as this in this equation, right? F ki value di phaki chuwi na an kharle values. So F ki sabla, let us write g capital M into small m divided by d square is equal to m into g. Right? So now we have to find the value of g, right? So g is equal to g rangda sarda dm didela multiplied do achu khilina divide na lali wa. So what we get is F hunda F mata g capital M into small m divided by d square into d chu khilini m chirwa small m. This small m, the small m you cancel do. So what we get is g is equal to small g is equal to capital G divided by d square. Gravity acceleration due to gravity and formula now while solving the calculations, calculation numerical problem solved acceleration due to gravity can be no object motion described here the calculation then g ki value di khadine fixed ra ta ding to continuously me che me che g ki value di khazir vela na 9.8 meter per second square ra the acceleration due to gravity ki exact value di re, right? However, in order to simplify the numericals ki calculation is a little thai chela jam nganjola thiba nangla, we will be given g ki value as 10 meter per second square. Calculation lelar tang chitu. Decimal make your number ki multiply tang divide tang chuna lela yorwa. So that is the reason why jam nganjola g ki value di ani thiba solve chitu 10 meter per second square te serious ra. However, g ki value takta de khazir bela na 9.8 meter per second square. Chaswa ta de thanda formula didwa g is equal to capital G m divided by d square lash dwa ta di nganzurwa kisi object earth ki surface ki thili na, then what happens, right? Earth ki surface ki thili na nganzu di distance di khari consider chir vela na earth ki radius di consider chir nganzu ki ra. So here we can also write it as g is equal to capital G m divided by r square. Earth ki radius, where r stands for radius of the earth. Right? So dila consider chi. Now we know that earth ki shape di is not a perfect sphere. perfect square yo mares ra radius of the earth pole ne ma equator cholo yondu pole nyu che ani equator chola radius di manga le gore ra ganzo earth ki sobda dil consider china r ki value di at poles nyunga yore equator la earth ki kima de la equator ki region sunzola r ki value di manga le gore. So since here gravitational the acceleration due to gravity the earth ki radius niga inversely proportional means radius khaze ki nyunga yona digam ki gravity ki acceleration due to gravity ki value di manga le re ra ani radius khaze ki che na digam ki gravity ki value di acceleration due to gravity ki value di nyunga le re. So pole ne ma equator cholo yondu and gravity ki acceleration due to gravity ki value jorwa di khache ki wala na nyuru pole la manga yore equator la nyunga yores khache na pole radius ki value di chunga yorwa so gravity ma che acceleration due to gravity di ma che and pole equator chola radius ki value di che yuza acceleration due to gravity ki and radius value di so that is how we explain the concept of free fall, right? Object and gravity influence na fall here na free fall che. And in that case, acceleration acceleration due to gravity, which is denoted by letter small g. Small g che formula di che value di 9.8 meter per second square, right? Earth ki surface ki chile na on the distance ki sabla khari consider chil wala na radius of the earth considered radius. So this is all about free fall. The last concept that we are going to discuss for today's class is mass and weight, right? So we have usually been using these two terms in a same context, right? We consider mass as weight and weight as mass. We use it in the same context, right? However, if we consider these two terms from physics point of view, they are completely different, right? Mass the weight niga and physics nalanga so consider chiyundi, they are completely different concepts. So mass is the net quantity of the matter, can be described as the net quantity of the matter, right? Whatever substance we have been given, the total quantity of that particular substance is called as mass. For example, let's say I have been given a certain amount of sugar, right? So we express the mass of that particular sugar in terms of kilograms. So we also have other units like grams, right? So if I say I have 5 kg of sugar, I'm referring to the mass of the substance that I have been given, right? So 5 kg indicates the mass of that particular object, right? However, what is weight? Okay, so now what is weight? If mass is the total quantity of the matter, how do we describe weight, right? So weight is nothing but the force, amount of force with which it is attracted, a substance is attracted towards the center of the earth, right? Chala ji in the center of the earth chola chuthingi yogi force ra chuthingi force dilang jo khalaida, we call it as weight. So it is the force with which an object is attracted towards the center of earth, right? So we can write weight is equal to force like this, right? So we can use the formula to calculate, we can use this formula to calculate weight of particular object, right? So here the force is involved, right? So we use acceleration due to gravity here instead of acceleration to calculate the force, right? So now here, mass described to we use the units like kilograms and grams. However, in order to quantify the amount of weight of a particular object, we use units like Newton, right? It is the same unit that we use for the force, right? Okay, now mass is a scalar quantity, which means it gives us the magnitude only. There is no involvement of direction here. However, in case of weight, there is a direction involved because gravity the in a downward direction. So here weight can be a vector quantity because direction is involved in this case, right? So this is how we differentiate mass and weight. Mass of a particular object remains same everywhere, right? Wherever we go, mass of that particular object remains same. However, gravity changes, right? Gravity changes according to the places. Like I mentioned before, if we consider the earth itself, the gravity value of G at the pole is greater than the value of G at the equator, right? So since the value of G is changing, the weight will also change. So weight will not remain same for the same object at different places. However, mass is going to be same for same object all over the places. Such a mass, but then weight will change, right? So this is how we differentiate the concept of mass and weight. Till now we have been using it in the same context. Weight is also used to weight has also been used to describe the mass, or in the same context, right? But then it is two different concepts here. Okay, now then in our syllabus we have also been given condition where weight of the object on earth is not same as the weight of the object on moon, right? So we will be discussing about the formula involved in calculating the weight of particular object on earth and the same object, weight of the same object on the earth and moon, right? So we'll be discussing about the formulas involved in calculating the weight. Okay, so like we discussed that weight of the object on earth and moon will not be same, right? So the ratio of weight of object on moon and weight of object on earth is approximately 1/6, 1:6. That means if we have to calculate the weight of object on moon, then what we do is weight of object on earth divided by 6. This is how we calculate the weight of object on moon, right? And if we have to calculate the weight of object on earth, then how do we calculate is weight of object on moon times 6. So this is the ratio that we have been given, right? The ratio weight of object on moon is to weight of object on earth is given by the ratio 1:6. And kissing on the weight of the object on moon se earth color weight di 6 ki divide chere. Weight of the object on earth se na moon color di times 6 chere. Let us take an example, right? Weight of a particular object on moon. Kisi moon color di 10 newtons ina. Weight of object on moon is 10 newtons. Then weight of object on earth will be weight of moon 6, right? So 10 into 6 will be 60 newtons, right? Okay, let's suppose weight of an object on earth is 10 newton. Then weight of object on moon will be 10 divided by 6, which is equal to 1.6 ones are 6, 6 ones are 6, 4 has 6, 6 is 36. Dukshine 1.66 bar Newton. Dukshine anzuki calculate chire. So this is all about the concept of weight of an object on earth and moon ra. The ratio di khandesli ra. they'll explain to me. It has been given in your textbook. So what I want you to do is kindly go through the textbook. Textbook nala number to see the ratio 1/6 khajini leidu. Weight of object on moon gi formula logic cure. Right? And then we have to calculate the weight of object on Earth by using another formula, right? So if we take a ratio of these two formulas, then we'll be getting 1/6 as the relative ratio, right? So what I'm assigning you here is kindly go through the textbook and find out how this ratio is coming to as 1/6. The ratio, the 1/6 learning, they're given to it. Now you have to find out the ratio, the 1/6 khandis leidu. Right? That we'll be discussing in our next class. The council nangle inda nangle ra. The any khandisle me any I will be explaining in my next class. Right? So with this we are done with today's portion. Please stay home and stay safe.